So we're going to go over your virtual number 3 assignment, make sure we understand what the answers were and why. So the first question, they want us to solve for the variable. We've been doing a few of these on the virtual assignments lately. Remember, solving for variable, we're doing opposite operations. So look at what's on the side with the variable. So on this problem, we see the fraction bar, which means they are dividing, means we need to multiply. Good. So they're dividing by 7. We're going to multiply by 7. Again, we multiply by 7 on both sides of the equation, keeps our equation balanced. Now, normally when we actually work this out, we would just bring this straight down. So 7 times 8 is 56. And then this other side, basically the 7's cancel, or you could get 7p divided by 7, and then when you divide that you'll get p. So normally it would be written like this. What they did is they kind of just went right to what our answer would be, which would be p equals 56. Nice thing about doing these problems is that we can just put that answer back in the original problem and see if it works or not. So instead of a p, we put a 56 there, and then we're seeing, does 8 equal 56 divided by 7? The answer is yes, then we know we got the correct answer. Number 2, we got a similar idea. Again, we're going to look on the side with the variable, the side with the k, and we can see they are adding, means we need to subtract. Good. So we'll subtract 17, do that on both sides of the equation, keeps our equation balanced, and we would get 12. Good. And again, really quickly, we could put that back in the equation. 17 plus 12 equals 29, so we know we got the right answer. Question 3, we've got a few different possibilities. A student purchased 7 binders for a total of $8.61, and they want us to write an equation that can be used to find the cost of each binder in dollars. So this was one I had to go back and manually grade because there are different ways you could do this. One option, you could have 7N equals 861. So 7 binders times whatever one costs equals $8.61. Another option, you could have something like $8.61 divided by 7 equals N. Or you could have N equals $8.61 divided by 7, same thing. So multiple ways that could be done. And then part B, what is the cost of each binder, would just be dividing that out. And if you divide that out, it would be $1.23 each. And again, a problem like that, if you don't know initially maybe what your equation is going to be, work it out and then think about, well, what did I do? Okay, I divided 861 by 7. To have an equal sign, I just need an equals. To have an equation, I just need an equal sign. So we can just put equals some letter. In this case, they told us to use N, and then I've got an equation. Question 4, a train was traveling at a constant speed. The table below shows the distance in miles the train traveled for the first 4 hours. Write an equation to represent the relationship between t, the time, and d, the total distance traveled by the train. So for this one, we look at the table, and obviously the hours, the time is going up by 1 each time. So increase 1 hour each time. And then if you look at the distance actually increases by 95 each time. So what that tells me, this was 95 miles, that was 1 hour, so that tells me that their rate is 95 miles per hour. If the rate's 95 miles per hour, the equation we talked about, D equals RT, the 95 miles an hour is our rate, so that means our equation could be D equals 95T. And then they have a graph that shows the relationship between T and D. if the train was traveling non-stop, how many miles would it travel in 5.5 hours? So that one we could just use the fact of it's going 95 miles an hour. If you wanted to, you could take your equation. You could say the 5.5 would be the time, and you could just multiply that, would give you the number of miles. Technically, you could figure that out without writing your equation down. You could say, I know I'm just going to be multiplying 95 times 5.5, and so that is 522.5 miles. So this is a good reason why it's important to know how these things relate to each other, because that's a partial hour. We can't just say, well, I'll keep adding 95 until I get there. Well, our next one would be 5 hours. Then we'd be at 6 hours. We passed it up. Okay, yes, you could figure out what's halfway in between there, but much easier if we can just understand that we would just be multiplying those together to get our answer. Question 5, they want us to find the volume of the right rectangular prism. So volume, we had a formula which was on your reference sheet, is length times width times height. So you might say our length is 1.5, our width is 1 1/4, and the height is 2. We're going to multiply these. Before we multiply, though, we need to change the improper fractions. Good. Now somebody might say, well, change them to decimals. On this problem, we could change them to decimals. That would work also. So 1 times 2 is 2, plus 1 is 3/2. 1 times 4 is 4, plus the 1 on top is 5/4. And then the 2 we can put as 2 over. Okay, we multiply, so 3 times 5, 15 times 2. And denominator, 2 times 4, 8 times 1 is 8. Okay, so we got 30 divided by 8, so if we divide that out, 8's going to go into 30. 3 times. And actually we only have one answer that's even 3 and something, so we can verify this, but this will reduce down as 3 3/4, which would be answer choice C. Number 6, I would highly recommend drawing a picture, anything like this. Mr. Rollins has a rectangular garden 14 feet wide, 20 feet long. So maybe we draw a picture out. He decides to extend the length of the garden. Extend the length. So the length right now is 20. We're going to extend that. So the 20 gets extended. And it says we're adding another 70 square feet. And the question is, how many feet does Mr. Rollins plan to extend the length of the garden? So some of this stuff we need, some of it's extra information actually. Okay, without a whole lot of thought, some of you guys might have said, something about, well, there's a 14 and a 20. I'm going to multiply. I'm going to find the area of his garden. That's fine. That's not what it asks to do, though. So what we got to do, we got to deal with this extended part. So the extended part, using our equation here, do we know what the area of the extended part is? What is it? 70. Okay. Do we know what the length is? No, length is whatever they added on here. Do we know what the width is?
Yes.
What is it? 14. Same as it was on the other side. Okay? So what that tells me, I had an equation. I knew 2 out of the 3 variables means I can find that third variable. We can do that by solving the equation. Over with the L, what are they doing? Multiplying means we need to divide. So we divide by 14 on both sides. And when you divide that out, you get 5. So that means the length must have been 5. Okay? Now, we had a discussion. In the other class, somebody says, well, I'm just going to, I looked at that and I could tell I need to just take 70 divided by 14. That's fine. What's going to happen down the road, you guys will get more complicated formulas and you'll have to do more than one step. Okay? In a couple years, you might have to first multiply some numbers together and then divide and then take a square root to figure out what your answer is. So the more practice you get now with actually using the formula, substituting into the formula, the easier it'll be for you later when you have more steps that you have to do in order to actually find your answer. Number 7, Kylie fenced off part of her barnyard to keep her chickens safe. The part of the barnyard she fenced off is represented on the coordinate plane below, where the units are in feet. What is the area in square feet of the part of the barnyard she fenced off? Write your answer as a decimal. So first of all, we have to recognize this shape is a trapezoid. Okay, so on a trapezoid we have a formula for that. Now one thing about a trapezoid is I know I have two bases and they are parallel to each other. So I'm going to turn this thing. I know if you guys were doing this on your computer screen you couldn't have turned it that way, but we'll look at it this way, and then you could have just drawn it on a piece of paper, sketched it on your piece of paper, and then you can turn your piece of paper, right? Okay, so what we're going to do then is just count how many units we have for each side. So this, I just noticed something. They are going by halves.
I got that wrong.
Okay, so -3 to 4.5. That would be 3 plus 4.5. That would be 7.5. Half as much as what we thought it might have been. Okay, this other one we're going from -3.5 over to, well, this was 3.5. I'm getting turned around because I turned this graph. We'll do this just for a minute. So we're at 3.5 up here, going to -4.5. So that'd be basically 4.5 below, 3.5 above. That's a total of 8. So we got an 8 there, we got a 4.5 over here. So now we can find our area. What we need to remember here is that the bases are parallel. So the parallel bases would be the 4.5 and the 8. And the height would be 7.5. Now this one, it said to write your answer as a decimal, so if you want to go ahead and change these to decimals, actually would be okay. So you work this out as a decimal, it's 46 and 875 thousandths, and this was in feet, I believe, so square feet. So that one, we really got to watch that, because that's very easy just to get caught just counting squares instead of looking that they're going by halves. They're going, normally we might think they're going by ones, but going by halves is going to change our answer, obviously.